Hello everyone, I'm Prajwal of BCA First Sem. Today I'll be explaining about sets, relation and functions. First, let's move on to the definition of sets. A set is a collection of distinct objects or elements. These elements can be anything, numbers, letters or even other sets. Sets are often represented using curly braces. Operations on sets include union, intersection, complement and subsets relationships. For example, in 1, 2, 3 is a set containing the numbers 1, 2, and 3 elements. So there are 3 elements in one set. It's known as it might be numbers or anything. Next, these are the examples for sets. Uh, Set of natural numbers. A set which contains the natural numbers which is from 1 to infinite. Set of even numbers. It is a set which elements are only even numbers. So a set containing only even numbers is known as set of even numbers. Set of prime numbers is a set which contains only the prime elements, which is 2, 3, 5, 7, 11. So these are the examples for sets. Next, let's move on to the definition of relations. Relation is a connection between two or more sets. It defines how elements from one set are related to elements in another set. Relations can be represented as tables, graphs, or ordered pairs. Common types of relation include equivalence relations, reflexive, symmetric, transitive, partial order, or functions. Example for relation: parent-child relation. Alice, Bob, Alice, Carol, Bob, David. This relation shows that Alice is the parent of both Bob and Carol. So here we can see in two sets there's the same name, that's Alice, and the next name is Bob, and in the next set it's Carol. This shows how the connection between the two sets are, and this is known as the relation. So here we have one more greater than relation: 3, 2, 5, 2, and 5, 4. So there are 3 sets, and in this 3 sets we can see that the numbers where the first number is greater than the second. So this is how the relation in a set works. So next, let's move on to the next topic, that's function. So a function is a special type of relation between two sets where each element in the first set maps to exactly one element in the second set. Functions are often denoted using notation like f of x is equal to y, where f is the function, x is the input, and y is the output. Function can be classified as injective, one-to-one, surjective, onto, or bijective, both one-to-one and onto. These concepts are essential in various areas of mathematics and computer science, including set theory, discrete structure, graph theory, and formal logic. So, function is a special type of relation where between two sets, where one element of one set maps exactly one element in the second set. So we can say that we can one element from one set is exactly the same or maps the same element in the second set. So that's how the function definition goes. And example for function: linear function, f of x is equal to 2x plus 1. This function takes an input x and produces an output by multiplying it by 2 and adding. So you can see that function f of x is equal to 2x plus 1. Here we are multiplying the function twice and adding it once. That's known as linear function. And square function, g of x is equal to x power 2. So this function uh, squares the function, which means multiply the function by itself by squaring it. This function calculates the square of the input x. Identity function h of x. The identity function simply returns the input as the output. The identity function gives the same same input as the output. So in these example, you can see how sets collect elements, relation, establish connection between elements, and function map element from one set to another. These concepts are essential tools in mathematics and computer science for modeling and solving various problems. So let's move on to the conclusion. Sets provides the foundation for defining relation and functions. Relation describe how elements in sets are related, and functions are a special type of relation with specific properties that make them extremely useful in various mathematical and real world applications. Thank you.